So in the last video, you learned how to find the next greater element using stack. You have mastered looking for the largest number, but here's the twist. What if I flip just one thing in that algorithm and we are finding the smallest element instead? Same stack, same order of end time, but a completely different problem solved. This is nothing but finding the next smallest element, and you already know 90% of the solution. Now, before we begin, if you have been finding my lectures helpful, don't forget to hit the like and subscribe button. Your support really motivates me to create more DSA related content. So let's start. Now over here, I have just converted this array into a bar graph. Okay. Now, if I'm standing over here, I do see that the next smallest element for this is 1. For 4, it is also 1. For 1, I don't see any smallest element on the right hand side. So I basically say it is -1. For 6, it is 3. For 3, it is 2. For 7, it is 2. For 2, I don't see any element which is smaller than 2 on the right hand side. So for this, it is -1. For 9, it is 8. For 8 also, I don't see any element. So it will be -1. And for 10, it is -1. Okay. So this will be our answer, in which we need to store it in an array and we need to return it. Okay. So talking about the first approach, now basically what you can do, standing over here, you can just have one simple for loop in which it will iterate on the right hand side. And if you found any element which is smaller than 2, that element will be the next smaller element for this. Okay. So here in this case, it is 1. And we have to do this for all the values. Okay. So basically, I will be having 2 for loops. So initially, you will be creating a resultant array in which the size will be n. Now, for I equals to 0, I is less than n, I plus plus. Okay. Then we will be going to have another for loop in which j will be starting from I plus 1, since we are scanning towards right hand side. J is less than n, j plus plus. Okay. Now here I'm going to have a condition. If my array of I is greater than array of j, so I have found an element which is lesser than current element. Okay. So I'll have resultant of I as array of j, and we will simply break from the current for loop, that is inner for loop. Okay. But here in the above example, we can see that, let's say for element 2 for this, okay, I don't see any smaller element on the right hand side. Okay. So for this, the answer is -1. So basically what I'll do, I'll just have initially resultant of I as -1. Okay. Because we are not able to enter in this if case. Okay. So if you are not able to enter in this if case, I already have initialized -1 to it. And that's it. We are done for this approach. And at last, you can just return the array. Okay. Now talking about the performance of this code, the time complexity will be order of n square, since it is having 2 for loop, and the space is order of 1. Okay. Guys, again, I'm saying that this is not considered as an extra space. Okay. Here we need to return it in the form of an array, and we have not taken this for our purpose. Okay. Hence, the space complexity is order of 1. Now, we need to optimize this. Okay. So the approach to, now I believe that you already know that how we can solve this. Okay. So basically we will be solving this using a stack. For those who have not seen the previous lecture, okay, for them I will be telling. Let me take this example. Now, so basically we will be traversing from right to left. Okay. Because if you're traversing from right to left, then let's say for this element, okay, I will be knowing that what was the future next smallest number. Okay. Since we have traversed it, okay, I will be basically storing this to in some data structure, and that data structure is nothing but a stack. Okay, now since I have stored this, so I know that for this element the next smallest number is 2. Okay, so this is the idea. Now let me create a stack. Now the second point would be that if I'm standing over here for this element, can 9 8 can be the answer? The answer would be no, because since I'm standing over here, okay, for this element this will be our answer, not 9 or 10, right? Since we are looking for the next smallest element. Now I will be starting with the approach. So over here this stack is empty, so I will have -1 for this. Okay, and then I will be keep storing. For each and every iteration I will be storing the element into the stack. Now we are standing over here, and over here I can see that for this element 10 can never be the answer if 8 is there, right? Because 8 is smaller than 10. So if that's the case, then I will basically pop it. Okay, now since the stack is empty, so I'll have -1 over here, and I'll push 8 into it. Okay, and I'll move forward. Now for 9, the stack is in the stack, the element is there, so I'll have 8, and I will push 9 into it. Now I'm standing over here, and for this, see guys, for the element before that, 9 can never be the answer, okay, if the 2 is there, because 2 is smaller than 9. So basically I'll keep popping unless and until I don't see any element which is smaller than 2. So I'll pop this as well as this. Now over here I do see that the stack is empty, so I'll have -1 for this, and I'll store 2 over here. Now I'll move forward. So for 7, 2 is the answer which is present in the stack, and I'll push 7 over here. Now for element over here, 7 can never be the answer, right? Why? Because 3 is there, which is smaller. So I'll basically pop this, and over here I do see that 2 is smaller than 3. So I'll not pop 2, and for 3, 2 will be the answer, and I'll store 3 over here. Okay, now for 6, I know the answer which is present in the stack, which is 3, and I'll store 6 over here. Now for 1, for this element, 6, 3, and 2 can never be the answer, right? So I need to pop all those. And since the stack is empty, so for 1, -1 will be the answer, and I need to store 1 over here. Now for 4, 1 will be the answer, and I'll push 4 over here. And for 2, 4 can never be the answer, right? So I'll pop it. And why I'm not popping this 1? Because this one is basically smaller than 2. So I'm not popping it. And for 2, the answer will be 1, and I'll store 2 over here. Now I can simply terminate since I have reached to 0, index 0. Okay, so in this way, basically we will be solving this problem. Now let's talk about pseudocode. First, I will be going to create the hash map as well as stack. Why I'm creating the hash map, you can just refer to my previous lecture. Okay, so in this way you can create the stack as well as hash map. Here I have used Java. If you want to know about C++, JavaScript, Python, and so on, you can basically Google it. Now see guys, over here, these values actually I'm storing in a form of a pair, and it will be stored in a hash map. So for 2, the answer is 1. So I will be storing it in a pair inside the hash map. Hence I have used hash map over here. Now I will be having a for loop in which I will be running from -1, and it will be gone to 0. Okay, now first I need to check while array of I is lesser than stack, top of the stack. Remember, if the top of the stack is greater than the current element, then basically we need to pop it. Okay, and we need to keep popping unless and until I don't see any element which is lesser than the current element. So I'm having a while loop. Now over here, since I I will be finding the top of the stack. So it might happen that the stack might be empty. So this will give us an error. Hence, I will be first checking whether the stack is empty or not. So stack dot size should be greater than 0. If it is, then I will be moving for checking this. Okay, and if both the condition are true, then I'll basically popping the element from the stack. Okay, so this is for the while loop. Now after popping, I need to store the answer. Okay, so hash map hmap dot put the current element and what is present inside the top of the stack. So stack dot peak. This will be giving me what is present inside the top of the stack. So over here also I am having the peak. So if the stack is empty, this will give me an error. So again, I need to have some condition. First, I need to check if stack.size if it is 0, then I need to store -1. So hash map dot put array of I comma -1. Okay, so over here we can see that when the stack was empty, okay, the answer was -1. So hence I am doing this. But if the stack is not empty, then I will have this condition. Then I will have this function. This one. Okay, now I have done with the storing part. Now, as I told you that for each and every iteration, I need to store the current element into the stack. So stack.push current element. And that's it, we are done. Okay, now talking about the performance of this code. Here I have taken the help of one single for loop. Okay, so the time complexity will be order of n. And since I have taken the help of stack as well as the hash map, so the space will be order of n. Okay, so this was the optimized approach. Okay, I believe that you got it. If you didn't, I'll advise you to please watch my previous lecture and then try to dry run this code as well. Okay, if you found this video helpful, make sure to hit the like and subscribe button. You can also share this with your friends and in your group so it reaches to more students who are struggling with DSA. It helps me to reach more learners as well. So I thank you so much for watching till the end, and I'll see you in the next lecture. Then keep practicing.